Hello and welcome back. We're going to keep on rolling, and right now we're going to do week 3, number 6, binary tree level order traversal, and that is number 102, binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. Okay, so if you know the BFS versus DFS, this is probably a breadth first traversal, right? Oops. It's probably breadth first, right? It's not depth first. It's not going as deep as possible and then going one to the left and then going one to the left and then going one to the left. No, this is breadth first, right? We're going to go level by level, right? And that's going to be DFS, BFS, right? Okay, so in their example, there's this thing, this tree here, and each level is going to be put into its own list, right? So there's a 3, 9, 20, 15, and a 7, right? 3, 20, 15, and 7. Okay. So in this traversal, what's happening is they're taking this, let's call it this 3, right? And for this level, this is being put into a list, right? 3. And then for this next level, this is being put into a list, right? 9, 20. And then for this level, this is being put into a list, right? And that's going to be 15, 7. So you can see that, in this traversal, we'll call that 1, 2, 3, we're taking all of the children of this level, putting it into a list, and putting that into the results array, right? The results has some array, and that's going to be appended these lists, right? So when you're thinking about the code needs to basically take a level, right? Put all elements else into a list, into in list, right? And then list goes into results. And then also in that level, take all children, and then basically replace the level with that children, right? So let's say we're going to start at this first level, right? The first level is going to be the root, so this is going to be the root. This is going to be the single item that's in the level. It's going to look left, it's going to look right, and then it's going to put these 2 items in a list, and that's going to be the new level, right? So this new level is going to do the same thing. It's going to put itself into results, right? It's going to do this step right here, put itself into results, take its children, put it into the new level, right? And if there's no children here, you notice how there's no left, there's no right here, then we're not going to do anything with those. We're going to go into this level. It's going to take its children and put it into the list, right? And then that's the end of the iteration, right? And it's going to be this code right here. So more specifically, let's think about how to write the code. So function solution. Solution takes a root. And what's going to be the level, right? So the level is going to start as this root. Let's say this is a list, right? It's going to start with a single thing. It's going to be the root. And while there is a level, or while the level is any length, I guess. So while length of level is more than 0, we're going to do these 3 steps, right? We're going to, so for node in level, we're going to accumulate the children. So let's say there's a children's array. Right? And then we're going to accumulate itself, right? So it's the levels values is some array as well. And then for node and level, we're going to populate both this and this, right? And then at the end, level equals children, and results, we're going to make sure we append the levels values. Okay, instead of these arrows, I'm going to make this a little bit more clear. You know, if there's a node dot left, you know, push that to children. If there's a node dot right, push that to children, and then, you know, you get it. You get add itself to node dot values. So this is basically the code that represents this diagram, right? So it feels pretty clear. I feel like there's this one's actually surprisingly easy for a medium, because once you get the BFS down, you understand that this is just the BFS with tracking certain information. So if you've done any other BFS problem, this should look very, very familiar, right? So let's write this code here. So the level equals the root, and we're going to put that in a list so we can deal with the list every time we do this. And while the level, or the length of the level, is greater than 0, let's do a children array, right, that we're going to use for the new level. Let's say the level values, or we can just call it values, array, right? And then for the node in level, right, we're going to add children if there is a child to add, right? Children append node.left if node.right, children append node.right, and then we also want to add the values, right? Values append node.p. All right. And when this is done, we've collected all the values, collected all the children, forgot to create a results array here. So we're going to create a results array, and at the end of it, we want to return results. So we want to do something, right? We want to affect results in some way. So results is going to be appended with these values. And then we want to rewrite level, right? So the children are now the new level. So we're going to rewrite that level. And this should be exactly what we drew here, right? Oops. So it's not node.p. P is means nothing. It's node.value. Aha. So if, okay, funny. So if this is none, so when would this be none, right? Well, what if the root was none? Let's think about that edge case, right? So if the root is none, let's return an empty list, right? Or I guess you could say, if you start with a results array, so you got to make sure you always deal with your edge cases. You should do it before you click run, and that's what we'll do next time. But this should handle that case where root is none, right? Because if root is none, we want to just return empty list, right? Otherwise, we're going to create this level with the root in it. If it was none, we have a list of a single none in there. And then, you know, we still have this while level. I believe in Python, it checks if the level is empty. So I guess I could have done while level by itself. Let's see if what I said was right. and then children is this list, values is this list, and we're doing, what we're doing here in blue. We're going to put that into some list, and then we're going to append that to results. And then in green, we're going to take 9 and 20, put that into a list, append that to results. And then in yellow, 15 and 17, put that in the list, append it to results, and continually change level until it's done, right? So what happens here? I'm going to go ahead and make this really clear. At 15 and 17, because there's no children, then, children on line 17 is an empty list. It never gets changed, right? So here at line 29, level gets swapped with children. Children is an empty list. On line 16, level is an empty list, and we don't go into this while loop anymore. All right, so we got decent runtime, 90%, but most importantly, we need to understand the time complexity. What we're doing is just going through every single node, not doing any extra computation. So this is an O of n operation. All right, thanks a lot. Thanks for watching, and we will keep moving on, and hopefully you will join me for the next ones. Please like and subscribe. Leave a comment if it's helpful. And if you want me to do any of these problems, if you have an interview coming up and you think one of these is most important for you, go ahead, leave a comment, and I'll tackle them. And I will see you next time.